Lesson 9.2 continued. Nth term test for divergence. If a series converges, the limit of its nth term must be 0. Now, please be careful on this one, because just because the limit of your nth term is 0 does not mean it converges. Okay? You have to know that if your series always if you're talking about a series that converges, then we know that the limit of its nth term is 0. So the contrapositive gives a useful test for divergence. So that means that if the limit does not converge to 0, the series must diverge. So it's more of a test to see if something diverges than to see if something converges, okay? So if you take the limit of the nth term and you get something other than 0, then you know that that is going to diverge, okay? That's called the nth term test for divergence. So let's look at some of the examples. Determine whether each series converges, diverges, or I'm not able to determine. Okay, so for part A, we are going to look at the limit as n goes to infinity of that nth term, n squared over 5n squared plus 4. You know that we have looked at the strong terms, the lead term in the numerator divided by the lead term in the denominator. We've canceled those n squareds and we've gotten 1/5. So you can do that. You could also divide everything by n squared, because you want to divide everything by the term that will get rid of all your n's here. So if you divided by n squared, divided by n squared, divided by n squared, that would give you the limit as n goes to infinity of 1 over 5 plus 4 over n squared. And now if you put infinity in, this one goes to 0. So your answer would be 1/5. Since 1/5 does not equal 0, we can say by the nth term test, the series diverges. Okay, part B. This one we're going to look at the limit as n goes to infinity of n over n cubed plus 1. And we could do the same thing by dividing by n cubed. Every single term gets divided by n cubed. The lead term in the denominator. So this is going to be 1 over n squared divided by 1 plus 1 over n cubed. Oops, I forgot my limit. There we go. And when I put infinity into n, I get 0. The only thing we know is that the series may or may not converge. Okay, this is not anything that the nth term test is going to do for us. Okay, we have to know it converges first, right? So if a series converges, the limit of its nth term must be 0. So, but you cannot do it the other way, okay? Where, oh, if it's 0, then it converges. That one doesn't work, but the contrapositive works. So if it does not converge, then the series must diverge. So, or if the limit does not converge to 0, excuse me, then the series must diverge. So I'm going to put little star here just because the limit of the nth term is 0. Does not guarantee convergence. Okay, so that one is going to be not able to determine. Okay, for part C, we would look at the limit as n goes to infinity of 1 over n, and we would get 0. But again, the nth term test for divergence does not apply. Comma, because the limit of the nth term is 0. It only applies if the limit of the nth term is not 0. Remember, it's the nth term test for divergence. And then we can say it diverges. Right now, we can only start thinking about what the partial sums are adding up to. So we can start looking at the partial sums. Start thinking about what the partial sums add up to. We will learn the answer to this in the next section, but this one actually does diverge. But if we looked at the partial sums, like let's say the sum of the first 4, we've got 1, because 1 over 1, then 1 over 2, then 1 over 3, then 1 over 4, right? So if we looked at that, it's adding, but it's not going to go to 0, right? So since you can clearly see that the partial sum is not going to be 0, then of course that's not going to be the convergence number for that problem, or for that series. Okay. So again, that one was not able to be determined, okay? So A was diverges, B was you can't determine it, and C was you can't determine it. But we will find out about this particular 1 over n. We'll find out about that coming up. Okay, example number 8. The nth partial sum of a series, summation from n equals 1 to infinity a sub n, is given by s sub n equals n plus 2 over n plus 5. Write a rule for a sub n. So let's just think about what a sub n is equivalent to, okay? We've got a sub 1 plus a sub 2 plus a sub 3, or actually I'm talking about what this is equivalent to, plus a sub 4 plus dot 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 plus a sub n minus 1 plus a sub n, okay? So this would be, this whole thing is the sum of the nth term, up to the nth term. Now, what about just to there? Okay, that would be the sum of the n minus 1 terms. So that means that the sum of the n minus 1 terms plus a sub n is equal to the sum of the nth terms. So we can say that the a sub n is equal to the sum of the nth terms minus the sum of the nth minus 1 terms. And they have just told us what the sum of the nth term was, right? They said, oh, that's n plus 2 over n plus 5. They already told us that. Look, it's right here. And then if we wanted to, we could say, oh, well, then that means the n minus 1 term, basically I'm just putting n minus 1 in for n, putting n minus 1 in for n on this one, there's the sum of the n minus 1 terms. If I add like terms on the second term here, I'm going to get n plus 1 over n plus 4. Now, if I wanted to add those two together, my common denominator is going to be n plus 5 times n plus 4. That means that this one gets multiplied by n plus 4 over n plus 4. This one gets multiplied by, and I should probably do it in a different color, but n plus 5 over n plus 5. To get that denominator, this one was n plus 4 over n plus 4. And so we end up with, I'm going to go ahead and multiply these out. N squared, I've got a positive 4n and a positive 2n, which is a positive 6n. Positive 4 times positive 2 is positive 8. Minus, I almost put plus, sorry. Minus, we've got n squared. Then I've got a positive 6n, but there's a negative there. So I'm going to say negative 6n. Positive 1 times positive 5 is positive 5. And then I can get rid of, oh shoot, sorry, this is negative 5. When my phone rang, forgot to distribute my negative. And so this ends up giving me, oh, the n squareds cancel. And this ends up giving me 3 over n plus 5 times n plus 4. So that is my a sub n. So they asked us to find our a sub n. 3 over n plus 5. I wrote 4 first. N plus 4 times n plus 5. That is our answer to that example. And the last one. The nth partial sum of a series is given by find a sub 6. So again, a sub 1 plus a sub 2 plus a sub 3 plus a sub 4 plus a sub 5 plus a sub 6. That's going to be my partial sum of 6. This one is going to be my partial sum at 5. So I know that my a sub 6 is going to equal my partial sum of 6 minus my partial sum of 5. So if I know my partial sum of n, I can find my partial sum of 6. So if I say that this is my partial sum of 6, then I'm going to be putting in 6 squared plus 2 over 6 plus 1, and then minus my partial sum of 5, so minus 5 squared plus 2 over 5 plus 1. So 38 over 7 minus 27 over 6. I changed these both to 40 seconds, but I actually could have divided by 3 here. If I divide by 3, I get 2. If I divide by 3, I get 9. And then I could have made my common denominator 14. So I would have only had to multiply by 2, so times 2 to get 14, and then times 7 to get 14. And that would have given me 76 minus 63, and that would have given me 13/4. So the sum, or the a sub 6, which is the 6th term, is going to be 13/14. Okay? And there's one other thing that I'm going to make a video on, and that is how to put some of these sequences into the sequential portion of your calculator so that you can actually see what they look like being graphed. If they're, going like that, you can see, or